Hello everyone, welcome back to my channel. So in today's lesson we are going to treat automata theory, which is part of mathematical fundamental for computer science. Of course, automata theory is just a study of finite state machine that deals with language recognition, which is part of a language translator. As you know, of course, for computer, we need to give an input in order to receive an output. So this output can occur in two ways. It can either be finite or infinite. But most often what we recognize in our daily basis is the finite automata, wherein we have two types of this finite automata, which is deterministic and non-deterministic. So for deterministic finite automata, we have a specific endpoint to treat this type of problem. For an example, if you are using an elevator taking from the ground floor to the 6th floor, our finite state here is the 6th floor. So if you are moving from 1st floor to 2nd floor, your finite state is the 2nd floor. So this is how they do these programs in order to perform this type of operation, either in electronics or in any computer science field. So this is a very important aspect in computer science engineering in terms of definite and indefinite automata. So here let's see, for finite automata, we have 5 tuples we use in order to reach to the final states. So here let's see, these 5 tuples are, so here we have our machine, which gives us this 5 tuple. The first one is the Q, which is the finite states, and this is the alphabet. But in this case, what we are going to use here, as you can see, this one is just the machine language wherein we can use zeros and one. But for normal alphabets, we can use alphabets from A to Z. But here, we only consider here the computer language, which is 0 and 1. But in subsequent problem, you can see where we can use the alphabets. So this is the alphabet, this is the finite state, this is the alphabet, and this is the initial state. Because whenever you want to move to a certain point, we need to have an initial point where you start, the starting point. So this Q naught is your initial state, and F is the finite state, which is the final, and this one, tau, is, this is the transition state. Or sometimes you can use any letter, you can use lambda, you can use phi, you can use any one. Psi, so we use this one as our transition of the finite states. So let me just state these ones here. So our Q is our finite state. Finite states. This is our alphabet. Finite alphabet. Then this is our initial state, Q naught, initial finite state. F is our final state. Sometimes we refer this one to as, if it's final, we said it's a finite state of these final states we have, because this is a final state, which is F. And of course, the last one is the transition. The transition of states. So now let's see here a diagram, a block diagram that illustrates the operation of these ones here. So first, of course, we have here our inputs. This is our inputs here. So of course, from the inputs, we come to our states, finite states. This finite state, we use Q. As you can see, we have the initial state. So this one, we can start from here Q0, then it goes Q1, Q2, Q3, Q4, and so on. So this one comes till the final state. Of course, after this final state, we have here, which is the output. Our output here is the final state. So at this output, you can either accept or reject. So we are going to see here, this is the finite state. Finite state. So now you can see from the initial state, which is the input, here is the input, we come to this finite state, wherein we have different variables, Q0, Q1, and so on, then before we get our output. And this output can either be accepted or rejected by the machine. So we have two examples on the board here, we can see. The first example here says, design a deterministic finite automata language wherein you end with, this is the word, end with 0, 0. So here you can design a state using all these parameters wherein you have a finite state, finite alphabet, this initial state, and final state, then use this transition state. So let's see here. But first, what you need to be mindful here is this statement. You design a deterministic finite automata language that ends with 0, 0. So if we start with our states here, our initial states, which is Q0, and we have here Q1 and Q2. So of course, if you want to say this is your, you can either choose, either you can say this is your final state, or you can say Q1 is your final state, or Q0 is your final state. It depends. So for us here, we say this is our initial state. So from this state here, we come to Q1 and Q2. So let's say our Q2 here is the final state. So the final state can either be designated by double circles, or we use star here like this. This tells us that this one is the final state. So now we want to design this state in terms of this condition. So we need to end this state using this 0, 0. So this is machine language. So let's see here. If you come here 0, then you come here 0, then this is satisfied, because from the initial state, you transition to Q1 and Q2 is the final. So what if you come to this one, then you said here 0. So if you come here 0, then 0 again, you reach to the final state. Then what if you use here, you say 0, 0. This one again 0, 0, because you come to 0 and 0, because we need to end this one with 0, 0. So if we say here 1, this one can either be 0, 1. So here you can say here 1, 0, 0, because we have another 0. Here again you can say 0, 1. You can say here 1 if you want to use the 1. Q0 to Q1, you take 1, 0, 0. So basically, if you are asked to solve short problem, the only condition needs to satisfy is what is given up here. If you are given 0, 1, then it means when you come here, 0, irrespective of the number of zeros or ones you use, the final state, which is Q2, supposed to be 0, 0. So here, if we say 1, here we can also say 1. If you come to Q0 here, you come to 2. You can't just come here 1, then 0, 0. Okay? because we have two zeros here, so if you come here from Q0 to Q2, 1, then you come again 0, 0. So this is the final state. So this is just the representation, the design of this deterministic finite automata. So now let's see here another one. This question is a bit different because this one we need to design a transition table, and of course we can also draw this transition of these states wherein the ending again is 0, 0. So we can also use the same diagram, but first we need to have a transition table. So let's see here. So first, you can draw this same, you can use the same diagram or you draw a similar diagram wherein your initial state is Q0, and here you have Q1 and Q2. So now let's see. So the condition here again, this one ends with 0, 0. So here we can say 1, we say 0, this one comes again 0. We can use here 0 and another 0, this comma. Then we can start from here. We'll come here again 1, 1, 0, 0. This one can either come this way or it comes this way. 1, 0, 0. Or this one you can have here 1. This one again you can have 0, 1. Because our endpoint here is 0, 0. So this is our final state. This is our initial state. This is the transition from this to Q1, from Q0 to Q1. The transition is this one. So this is our initial state. So now let's do our transition table. Transition table. So this transition table, we design the transition table according to these states here. So first we say Q0 comes with arrow, then we have Q1 and we have Q2. As I said, you can either give 2 circles or you give a star to this. So from this table, these are the inputs, these are the states, these are the inputs. So we have here 2 inputs. The inputs can either be 0 or 1. So here we can say here 0, here 1. So now we come back to this Q0. So we check Q0 0. Q0 0 is Q1. So Q0 0 will fill this as Q1. Then we'll come again Q0 1. Q0 1 we can either be Q2 because this one comes to final state, or we can say Q0 1, we can also say Q1. So let's just see, but this one we can't say Q1 because this one needs to end with 0, 0. So here we can use this Q0 1, which is Q2. Then Q1 0. Then Q1 0 here is Q2 again. Q2. Then Q1 1 is Q2. Then we check again Q2 0 is Q2. Then Q2 1, no, here no 1. So if you want, you can add here 0, 1, or you can say, because there are no Q21, so you can either leave this space blank, or you decide to change here, you add 1 here. So if you say 0, 1, then this one will be 0, 0. So let's just leave that one. So now we'll try to solve this problem using, so now we can say, we can use this as our transition. What is given here is 1, 1, 0, 1, 0, 0. So this is given, this one is given. So now our initial state here is this Q0. So now we have our transition, which is this one. So now we can say transition of this Q0. Now our language numbers here are 1, 0, 1, 0, 0. So now we can transition to this. We say Q0. Q0 will take this first one here, this first variable here, Q01. Then the remaining is 0, 1, 0, 0. So we come to this state. Q01 gives us, Q01 is Q2. So now we say Q2, comma, we take this one again, 0, 1, 0, 0. Then another transition, Q2, 0, Q2, 0. Then the remaining is 1, 0, 0. So Q2, 0 is Q2. So this is Q2, because here Q2, 0 is Q2. So we say Q2, comma, we take this 1, 0, 0. Then another transition. So Q2, 1, 0, 0. Of course, Q2, 1 is nil. This is 0, so forget about it. You can just say again, is 0. This is 0. So say Q2, comma 0, which is 0, 0. So Q2, 0 is Q2. Q2, comma 0. This is 0. So Q2, 0 again is Q2. Q2, comma 0. Q2, 0 is Q2. Q2, 0 is Q2. Say Q2. So as you can see here, our final state here is Q2. So when you solve this type of problem, you end up with the final state. It means this is accepted by the machine. So therefore, Q2 is a finite state and is a final state of this state, therefore is accepted. So you can also use another method in either for you to check either this type of language recognition or translation is accepted or rejected by just changing this one. You just change this one, like you have this one supposed to end with 0, 1. So now instead of 0, 0 or 0, 0, you can give here 1, 1. Then you check. You use the same approach to solve this problem. So don't forget to subscribe on the channel, comment and share. Of course, we have a lot to do. On the next video, we can see the other aspect of this type of problem. So don't forget to hit that subscribe button.